Hello everyone, I'm back after many hours. Alright, so we have an idea and let's implement it. Let's implement it. Ugh. What did you do? I have no idea what I did. I just... oh, this is not gonna work. This is not gonna work. Yo, this is not gonna work. I forgot how... is that T? Oh. Huh? D? Ah, you're destroying your stuff. Yeah, I'm gonna restart it. Oh, kill session. I thought it was new, right? Or yes. Yes, okay, there's a new session. And then I will do this. And then I will do this. There we go. There we go, code. Don't remember the... oh, this is bad. Code LLDB. There we go. Code LLDB. And this will go to the same place. And then we'll come here. Go to the same place.
Why?
Yeah, and... okay, we're actually good. So today is... I think it's for 12, right? This is for the 12th, yes. I think I did it wrong. Ugh. Wait, how do I get log? There you go. We'll reset here. Okay, so now we're gonna do 12. There you go. Alright, everything back in order. Oh my goodness, it took so long to get things back in order. Alright, so this one, so the ideal is we will first... okay, I should not write the idea, what I have. 3272. So we will first use DFS to find all the all the palindrome, right? All the palindromes given the length and the divisor k. Then for each valid and unique, it will be unique because the way we find it will always be unique, right? So for each valid and unique palindrome, we'll find we'll find the number of unique permutations, right? We'll find a number of unique permutations. Okay, so that's kind of how we will do. Let's see if we can implement it. So we'll have a long get, right, get palindrome, count, helper, DFS. All right, we need, what do we need? We need a vector of int. So this is palindrome. So this is this is the thing that we're building, right? This is the thing we're building, and we need index to know where we are. Okay, and we need to know the current. We need to know the index. We need to know the current digit, right? We have index, we have current digit, and after that, that's about it, right? We have the current digit, and yep. Okay. Yeah, that is about it. And what's the end condition? The end condition is, because every time we fill on both ends, right? We fill on both ends, which we can compute. And the end hits if the index is halfway through, right? So you fill it, and then we move the index forward, and the index is halfway through. That's when you end. That's when you need to do the check. Or of course, to do the check, you need a k, right? And that's about what we're gonna do here. Okay, so first thing we want to check if index is, so like if we have like 4, right? Say n is 4, so 0, 1, 2. If we hit 2, then that's bad. So we say it's large or equal to palindrome dot size divided by 2. So it's a 5. So 0, 1, 2, 3. So you had to hit 3. So 5 divided by 2 is not 3. Therefore, I need to do the size plus 1. Right, size plus 1. So if we have 5, then 5 plus 1 is 3. And 5 plus 1 is 3. 5 plus 1 is 6. 6 divided by 2 is 3. So when you hit 3, 0, 1, 2, 3, and that's the end. If your length is 4, then 4 plus 1 is 5. 5 divided by 2 is still 2. So you hit 0, 1, 2, then that's the end. So this is the end. So this is the palindrome. The palindrome has been formed, right? The palindrome has been formed. So we need to count. We can just pass this palindrome into the thing. Yeah, so we need yet another function. We call it long. Okay, so long number of permute. Right? So we'll pass this vector palindrome in, and that's it. We just pass it in, and then we'll pass it out. Of course, you forgot this has to be passed by reference. This has to be passed by reference. Okay, so maybe we should solve this problem first. No, let's do this one first. So that's that, and this one will basically just return num permutation of palindrome, right? So we just return that, then it's done. Otherwise, so we haven't reached it, and then we have the current digit. So we will set the current digit, right? And we'll move on to the next. Oh, hold a second. Actually, this is not right. We need to get a number first. Get a number. So we should say long num equal to 0, and we start from the beginning. We add it, move on, and then this one times 10, and then times 10. So basically what we're gonna say is for int I 0, int digit d of palindrome, we say num shall equal to num times 10 plus d. If num mod k is equal to 0, then we return this. Otherwise, we return 0. Right? So let's say 1, 2, 3, 4. So we start with the first is 1, and number 0, so we have 1. And then 1 times will be 12, and then 130, 120, and yep, I think this is right. So we have to do this check, and then we run this. And otherwise, we haven't formed yet. So we are at whatever we are at the moment, and we put the current digit. Now here's the thing, do you want to put the current digit here, or you want to move on to the next one? I don't think we should put the current digit here. This is not right. We should do the digit while we are looping. Right, so long total. This total just means given this, what's the total? Given this, what's the total, right? And then we're gonna loop through all possible digit options. So d equal to 0, right? And then say d is small equal to 9, d plus plus. Index is the place that we need to be. So we'll set the index and then move on. How do we set the index? Well, we say palindrome index shall equal to d. Palindrome how do we find on the other side? Well, index like 0, 1, right? So we need to go from the other side, moving the same. So the other side, if we want to move the same, what I can do is I get n out first. Okay, let's get n out first. Palindrome dot size. Okay, so here can make it easier. This will be n. All right, so be n, right? 0, 1. So n minus 1. So n minus index minus what? All right, let's try it. If we have 4 and index is 0, then n minus 1. If index is 1, then n minus 2. That's correct. If we have 5 and index is 1, on the other side is 5 minus 1 minus 5 is 3. 0, 1, 2, 3. And what if 0, 1, 2 is 2? 2 will be the same. Yeah, so we set both equal to d, and then we say total plus equal to DFS. Same thing, palindrome index plus 1 and then k. Right? So we just collect all possible sums out of this, and eventually we'll return total. That's just, at this position, right? At this position, what's the total? And it's based on the previous one, right? So previous is this. We'll go into because what we could do is we go to the next one, right? We go to the next one, and we'll collect all different possibilities for the next one, and the current one will swap to the next value, and we'll collect everything, and so the next value will collect everything, and then we'll go to the before. Okay, so that's that. Now we need to do this part. So this part, we have the palindrome, so we need to get a count out first. Okay, so let's say we get a count, and basically what we're trying to do is we'll permutate, right? We'll permutate, and we have the complexity of handling zeros, right? So we will do all the permutation, right? We'll do all the permutation, and we will hit because this is palindrome. So yeah, that's the thing. Maybe the easiest way is instead of doing this, we pass the counter. So I think if we pass the counter, it'll be more generic, right? But it's still the same. So we do a counter here, and we'll do here std vector int, right? We say counter will have a size of 10, and And then when we do this, right, when we do this, what we do is we say counter d plus plus, right? So we do the counter, and then we'll pass the counter here, right? So now we have the counter. So we can go through all of them. The first thing that we saw that has number, so we do a combinatorial. So does C++ has combinatorial? So let's say C++ combinatorial. Do they have that? Algorithm, combinations. Oh, because it's gonna be n choose something. What's the n? N can have at most 10. There gotta be a way to compute this, or doesn't it? We might as well just pre-compute it. All right, I think we'll have to roll it ourselves. Oh, you gotta be kidding me. You can have a paper on this. Permutations, this is the combinations, right? So it's going to be, yeah, I think I'm gonna roll it myself. N factorial divided by k factorial and n minus k factorial. I remember there's a trick to do, like n factorial is going to be 1 times 2 times 3 times, n minus k, right, times n minus k plus 1 times all the way to n, which means this part is n minus k factorial, and then n minus k plus 1 times n minus k plus 2 times all the way to n divided by k factorial and n minus k factorial. And this can be eliminated. So all we got left is going to be n minus k plus 1 times n minus k plus 2 times all the way to n divided by 1 times 2 times 3 times all the way to k. So that thing we can easily compute. So let's say 10 choose 3 shall equal to 10 minus 3 plus 1. What's that? It's 8, right? So 8, 9, 10 divided by 3 factorial, 1, 2, 3. I want to double check my math on this. So is this correct? We can actually calculate. This is 4. This is 3. This is 120, right? 120. So let's say 10 choose 3. Right, so 10 choose 3. 120, exactly, right? 120. So this is the algorithm that we're going to use, okay, when we do this. So I'm going to implement something called long combinatorial, right? N and then K, right? So what we're going to do is numerator, long numerator 1 and then denominator equal 1. Denom, num and denom. Num and denominator. So we say for int I equal to n minus k plus 1, I small equal to n, I plus plus, num times equal to I, right? That's this part, n minus all the way to 1, all the way to 1, all the way to n. And the second part is for int I equal to 1, I small equal to k, I plus plus, denominator times equal to I, and we'll return numerator divided by denominator. Okay, so that's combinatorial. So here what we have is long total, because we'll have all combinatorial for whatever we have for the first number. So yeah, the idea, this is kind of the epiphany I have, right? So if I get a count, like we have 2, 2, 2, 4, 4, 2, 2, 2, right? So what we do, we have 6 of this and 2 of this, right? So we have 6 of 2, and then we have 2 of 4. So what we do, we have 1, 2, 3, 4, 5, 6, 7, 8. So we basically 8, choose 6. That's all the 2's, but there's no permutation among them, right? So basically we say we have 3, 4, 5, 6, 7, 8. So how can we arrange them, put the 2 in there, like different ways, right? And then once we've done that, we will multiply with, because we got 6 out, so we have 2 left. So it will be 2 choose 2, which is just 1. So this is the total number of ways. So we're going to apply the same idea here. We say, let's also get a total here. So we need a n, right? And then we just say for int I, 0 I smaller than should be 10, right? I plus plus. Actually, let's call it digit. This should be digit, right? And then we'll have count is going to be counter d, right? If counter is larger than 0, we'll say total times equal to, yeah, because you can have different ways. So you need to, for each one, you can have all, for each combination, you have all these other combinations. So times equal to combination of n choose c. Oh, actually, let's call this k, right, to make it more explicit. So n choose k, right? And then n or minus equal to k, because we don't have as many open spot left. And we got the next one, we got the next one, we got the next one. So this is the total. Now we have to handle, we do not include do not include numbers starting with 0. All right, this is something we don't want. So we say if counter 0 is larger than 0, so we have a 0, then basically what we do is, and then this counter is throw away, right? This counter is throw away, so I've produced a new counter. So I just change on the counter directly. So if counter 0 is larger than 0, so what we do is we'll say total minus equal to, so we'll say counter 0 minus minus, right? We do this minus minus to say we put 1 0 at the front, right? So we want to see what the total number of varieties we can get for the remainder of them, right? That's what we want for the remainder of them. So total of minus equal to, again, num permutation, counter again, right? And n minus 1. So that's the total we can get. And after that, we put it back. So it's kind of backtracking to be safe, right? So we'll put it back and we'll return total. Okay, I think we almost there, right? So for here, we just call it DFS. We need a palindrome. So std vector int palindrome of size n. It does not matter what it is. And we don't need to backtrack because every time when we hit a new one, we'll just reassign all the numbers. So I don't think it's necessary to backtrack. Oh, and in this case, holy crap. Yeah, I see where the bug might be. So it's the question of, do we need to eliminate yeah, because it's recursion call. You know what? I think I shouldn't do it here. No. We just do that, right? We do it here. So we say we get a number, and we can get a total. We get num, perm, counter, and n, right? If counter 0 is larger than 0, right, so remove all the numbers, all the permutations, right? All the permutations that start with 0. So we say counter 0 minus minus total minus equal to, okay, this is not integer. This is long. Okay, this is long. And this will be minus equal to num permutation counter and n minus 1. So yeah, we do it here. And regardless, once we're done, we'll return total. And we don't need this, right? And see that we have to define total, so we can actually define total at the beginning because this is something that we all use. So I don't have to redefine it, we just set the value, right? So we say if it's this, then we'll return, otherwise return this. Okay, okie dokie. So this is going to be DFS palindrome for sure, right? We'll have palindrome, and then index will start from 0 and then k. I think we can just return this. All right, let's take a look. Let's see how this goes. Oh, that was not right. The second case is right. The third case is also not right. All right. We need to debug, which is fine. N equal to 3, k equal to 5. Let's debug this thing. I'm all for debugging this. N equal to 3, k equal to 5. Right? N equal to 3, k equal to 5. This shall be count good n and k. All right, where are you going to put? What I think is we will just put the breakpoint inside. Let's put breakpoint here, okay? And then we will build it. This is number 11, not 12. Okay, coming back here, F5, let's go. All right, we get it a little smaller. I don't need this. I don't need this. All I need is the local values. Okay, so we are here, right? And palindrome is nothing at the moment. And we are saying that it should not be, so we're coming down here. So the first one is going to be 0. Well, in fact, In fact, I realize what might be wrong. Hold on, let me exit this. We have this, the and that's possible, right? This is all the and that's possible, so we'll use that, okay? We'll use that. And basically, we say, can we, I think we can define it somewhere here, right? So we say public, can we have that with various length? I think we can, right? So std vector of vector, we say and digits. I'm not sure if it's so. If and digits basically it's 0 we don't have because k really cannot be 0. But if it's 1, right? This is 1. Then we say 1, 2, 3. 4, it can be 0. Well, n digits cannot be 0. No, we cannot, because n digit is 0. That means the first digit is 0, which is not allowed. So it has to be just 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1. 2 will be 2, 4, 6, 8. 3, unfortunately, will be everything. Our template, I forgot. I'm sorry. We have to do this, and then this basically we have to copy this. That's 3, right? 4, 5. 5 is by itself. 6, what's 6? 6 is same. 2, 4, 6, 8, 6, 7. 7 is going to be all of this. 8, 2, 4, 6, 8. No 0. This is just and a digit. 9. 9 is going to be everything. Okay, let's see. Can we? Is this allowed? Oh, I guess it is. It is allowed. Okay. So let's get down. So basically, this is the starting point. Ooh, the starting point. Essentially, it is first. Okay, so index. Index is 0, right? Index is 0. So we basically go down here. Okay. So if index is 0, then we'll go through the other one. If index is not 0, we'll go through this. Okay, so I have another idea. Vector of int all digits. Okay, all digits is going to be this, right? This is all digit. And in fact, I think we can do better here. Okay, I'm not sure. All digits and digits. Okay, I'm okay with it. All digits and n digit. We don't do it here. We do it here. Vector int digits. If index is equal to 0, digits shall equal to all digits k. Else digits shall equal to no, it's not all digits k. This should be end digits k. This should be all digits. And then for d int digit of digits, then we do this. Okie dokie. Let's now give this a shot. Let's see. 25. Should be 27. So we're getting close. We're getting close. I think maybe just a few edge cases that we need to work through. Which is fine. Let's go back to here. Let's debug it. Okay, where are we? We are here. Digits. Okay, so digits shall be size 1. It's just 5, which is cool. And this is palindrome. So palindrome will set this is a 5. Now we set this is a 5. Perfect. Total plus equal to, let's go inside. So we DFS again. We do that. Total is fine. Index 0, 1 shows still going here. Yes. And it's not. So we get all digits. So we get... I see the problem. All digits, I did not include all digits. You forgot a 0. Okay, let's see. We basically need to add a 0 to this. Okay, we got this one right, but we got this wrong. 2996. Oh, it should be 2468. Okay, so that might be a little bit too hard a stuff to go. So maybe we can do, instead of n equal to 5, let's say we do 1 6 2 6 3 6. How about that? 1 6 2 3 2 and then 3. Bloody hell, they're all correct. That is not how I would like it to be, but okay. 4 6 is wrong, so we'll do 4 6. 4 6 supposed to be 58. 58. 4 and 6. I feel like it's a little bit too much, but okay, let's try. 4 digit, okay, with 6. I think we need to write a separate just to check if it's palindrome. So we kind of have a base to compare myself to. So 4 digit, you know what? 6 divided by 6, 1, 2, 3, 4. So we have 6, right? Divided by 6. You know what? I think it's time to whip out a new thing. Let's just do it. I don't know. Where can I do it? Desktop. So this is definitely extra stuff. Yeah, let's go inside LeetCode. Let's go inside LeetCode again. And I'm gonna just do a Python script. Failed to run generator. No such. It's fine. I don't need. So what do I need to do? I say for rest equal to this. So I say for I in range, basically from 1000 to 9999. So I have to go like this, right? We also need to say check palindrome. We can check palindrome. If I divided by 6 equal to 0, and we also need to check palindrome. We say, how do we check palindrome? Def check palindrome. We have a value. How do we check palindrome? So we'll go front to back. NSTR with strn. Right, and 4. Low, high equal to 0, and len NSTR minus 1. While low is smaller than high, and NSTR low is equal to NSTR high. Low plus equal 1, high minus equal 1, right? And then when I get out, return low should be larger or equal to high. Right, because if it's this, if it's even, then low and high shall swap places. If it's odd, then low and high should meet each other. So okay, so that's that, and we just say if this and check palindrome I pass res dot append I, and then we will print res. Right? So that's my script, and I need oh, I am not in the environment. Oh my goodness. This is bad. This is bad. Hold on. Let me quit this one first. Okay, and I will do this. We'll have foo coming here, Python 3. Maybe I can do Shaban. I just do Python 3, it's fine. Python 3, foo.py. Okay, so these are the ones that we're looking for. All right, so these are the ones. Can I copy this? And can I put here? Oh, wow, I can. All right, so these are the numbers. All right, these are the numbers that we're looking at. So what we want to do is to make sure we have these numbers. 2112, 2442. Can I write it somewhere else so I can compare? I think I need to have some off-screen stuff. Okay, I'm gonna put this in my other screen so it'll be easier for me. Oh, I think I got the wrong one. This is the one I need to put in here. This is the one I need to put somewhere else. Okay, I'll put it down just to make sure that our algorithm runs to get the same value. Okay, so where are we? We're here, and then we'll go down, and then instead of doing this, we're gonna say n equal to 4 and then k equal to 6. All right, 4 and 6, build it here, and then we do a 5. All right. Yeah, so palindrome first is 2, so we expected 2, 147. Okay, so we have a 2002, but that shall be wrong. Okay, we get a counter. Okay, counter should be good. Counter should be good. And yeah, return 0, perfect. One. So 2112 is good. Coming here. Okay. So we need to do this. So 2112. How many? Well, 2112. Basically, I say it's gonna be 4 choose 2. That's it, right? So we have 4 choose 2 is going to be 6. So we have, in fact, we don't need this anymore. Well, I thought I can remove it. So window palindrome. So basically 1, 2, 3, 4, right? So we have 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1, 1, and I swap it, right? So we should have 6. So look at total. 6. Good. And it's is it 0? No. So return. Okay, now we have this total. This total is 6. Good. So basically 1, 4, 7, they should follow the same thing. So 666. We can actually calculate. Right, so this is 6, 6, 6, 6, 6, 6. Okay, this I don't know. 6. Oh, this probably where the problem is. This should be 6, 6, 6, and 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 66 down. But the expected is 58. 58. Are we? Oh, you see this? 2442 4224. Damn. Damn. Oh man. Man. Oh my. Okay, so we need a way. So yeah, at least we need to remove 6, right? I'm pretty sure there probably is another pair that we shouldn't do again. Yep. We have 4884 and 8448. So yeah, with minus 6, so 2, 1 get rid of. What else? That's it. 12. 70 minus 12 is 58. So all we need to do now is to use some mechanism to I don't know, what will be the easiest way to say like, yeah, we've done this before? Counter, but how do you save countering a map? I think the easiest way is to produce a string representation. Well, not necessarily a string representation of the number, but maybe the number itself. But the digits have to be sorted. But God, I have to sort this thing, right? Now I have to sort this thing. Okay, let's end right here. So essentially, what we're saying is I need another global here. We shall call it an ordered map, an ordered set of integer, no, of long scene. Okay, and when we are here, so we produce the palindrome, right? And we need to, oh my Lord, how do I even do this? I have to get another palindrome out. I don't know, man. I don't know. Unless you tell me, is vector hashable? It is vector hashable. I guess not. Which seems dubious. Don't do it. That's essentially what it means. Don't do it. Oh Lord. Yeah, you have to create a hash function for this. I mean, fair enough. We probably should. What do I do? What's your options? I think my option is simply before we do all this, right? Pattern has been formed. Okay, so first check whether the same digit pattern has been observed before. Can we just say check? Yes, yes, we can. Let's just simplify the logic. We get another one, so we'll say boolean has seen. We'll pass in the palindrome. Vector int palindrome. Okay, so we'll return whether it has seen or not. But I don't want to change it, so I'll do a copy. Right, vector int copy of palindrome dot begin, palindrome dot end. Right, so we copy it and we'll sort this thing. Copy dot begin, copy dot end, and we'll produce a str version of it. What's the recommended way to turn into turn a vector of digits into string? Is there an easy way to do this? Ugh, I don't like this one. So string stream. Meh. You just do that. You get a string stream and you just put it into the string stream. Okay. You want to do it that way? Okay. String. Oh, what's that? String stream. No, string stream. String stream. Right. Okay. And then for int digit of copy. All right. SS. So we do D. If seen. Oh, let's use this convention. I really like this convention. If seen dot contains ss retain has seen true, right? Otherwise seen dot insert, yes, and I'll return false. Okay. No match contains, no match insert. Really? Oh, I do long. Why you do that? Why you do that? Actually, that is a good question. What would be an easier way? Is a string easier, or is it doing long easier? Actually, I like long idea. Let's do long. So instead of doing this, I say long num, okay, equal to 0. And then for this basically num equal to num times 10 plus d. And then if it contains num, if not, we do this. All right, and then here, if index is this and has and a not has seen palindrome. Right, if it has not seen, then we do it. If it has seen, then we don't do it. Okay, let's see. Oh boy, this one, once it's done, it's gonna be majestic. So much. Okay, we have buffer overflow. What in the world? How? I mean, I'm not uh we didn't have them before. Fishy. I believe maybe this is the reason. Copy constructor. STD copy. I want a deep copy. It says just do this. Okay, we have a few options. One of them is, I think one of them is just use equal operator. Equal operator. So what you're saying is like that. I am not sure what happened. I am literally not sure. I think this one requires investigation. Okay, but if I can make this easier, I'll make it easier. Don't worry, we're getting close, right? We're getting really close. All we need to do is to verify that the things that we think is working is actually working. Right, so I need find room. Okay. Has not seen before, so seen, where is seen? Digits, this. $22. Ah. So that is already a bug. Well, actually, no, it's not a bug. It's fine, it's fine, this is fine. This is fine, and the number come out will be 2002. Alright, now we'll try. doesn't work, return 0, everything's fine. Next one is this. 1122 is fine, and then this is also, this is good, right? This is good, and the turn total is gonna be 6. Yeah. Next is 2222. This will be a false coming out. Next is 3. Next 4. Oh, debugging is also can make it easier because if you call a function, right? Damn. Okay, let's do that. Oh, let's do that after we're done. So we already have 4. Good. So now it'll be 12. Yep. Index is still. So index is still. Where is index? Index is still 1. Okay, 5 won't work. 6 won't work. 7 will work. 8 will not work. 9 will not work. Okay. We have 4. Right, index is still 1. Yeah, index is 0. Yeah, index is 0. Now index is 1. We add a 0 in it. Hold a second. What? How does palindrome become 0? How is palindrome become 0? I was at 4224, right? How has index become 4? Alright, something is very wrong. Something is very wrong, but in order to make the debugging even easier, I need another function to has seen combination get number from vector from a vector digits. So I believe this one's used a few places. Oh Lord, I should put this in the top. For example, here, this can be simplified. We can say, long num equal to get num cp. Right, and I remember there's another place here. So we can say get number palindrome. So we don't have to. Ooh, we do still need the counter though. Well, I just don't need this part. So we get that, then we get the counter. Screw you. Alright, let's do this. Get counter. I'm full on refactoring, man. Full on refactoring. Okay, that's not the right spelling. Counter D plus plus. Turn counter. Alright, so I have that, which means I do not need this. All this is useless. We just do vector, right? Counter equal to get counter palindrome. Cool. Anything else I need to be worried here? Well, I guess that's about it. We can try it again because we did find something very weird. Alright, 2222, 2332, 2442, 2552, 26677, 88. Okay, so and done, right? Next, D is, so index is 1, but we all go 9, so we run out of index, right? We run out of index, and now what are we doing now? Index is 0. Okay, so we now go 4. So no, okay. Index is 1. And we skip that. Skip that. So we get all digits. That's good. Now palindrome, so be 0. 0, that's good. And index plus equals to 2. Go here. Not seeing, so we put 44 in it. That is correct. Get number. So that shall be number should 4004. That's good. So this is not. So it turns 0. That's good. So we'll come into the previous. We back into here. So digit should be 1. Right? D should be 1. Where's D? D is 1. So become 1. 1. That's good. We're coming in. Index. So we go in. So it's 1144. Push in. That's good. 414. Get a counter. Nice. 414 is not divisible, so it's nothing. Get out. Perfect. Oh, I see how I know what goes wrong. I see what goes wrong. This shouldn't be put here. So this is the end. So we shall always put it here. There, this is the problem. Essentially, palindrome has been formed. We should say if this, if has not been seen, right? If has not been seen, then we'll do all of this, right? If it's not being seen, then we will do all of this. If it has been seen, then we don't deal with it. Okay, I believe this is correct. All right, let's try again. Oh, I think this is the most elaborate I've ever done. Dear me. Dear me, is this elaborate? Yep. This is elaborate. This is good. Let's restart some test case. Let's just be really nasty. I think this is the most nasty one, right? And we actually can throw, let's say, 8, 9, 7, 6, 5, 4. Throw some out there, just to try. Oh, I was so confident. Oh, we almost there. So 5, 4. We fall on 5, 4. That is very interesting. 5, 4 goes wrong. Oh, 5, 4. Okay. Question. 4, 4, 3, 4, 2, 4, 1, 4. Do we have a easier fail? Because 5 is a little bit too much. So we have 4, 4. Okay, 4, 4 is doable. So let's go back to this. Right? Essentially, we need a 4 and 4. 4 and 4. So 4 and 4, we just need this to be 4. Right? And then we'll come here. Dear me. That's a lot. That's a lot. That's a lot to deal with. Okay. Well, fear not. Let's handle it. Right, this is 4 and 4. So, right, this is 4 and 4. What we have? So we have basically 1, 2, 3, 4, 5. Skip. 6. So this we skip. This we skip. This we skip. This we skip, right? So we do this. That's 6. This. That's 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This I have. So this I have. 15. So 15. That's already wrong. Oh no, it's not. This is give me 90. But I only output 80. What? And this will give me, this basically is 4004, right? 40404400. Just give me 3. This give me 3. That's 6. right? That's 6. And then this give me 1. And this give me 1, so that's 98. Right, so basically plus 6 plus 2, 98. Okay. Alright, I only got 80 out of this. That's weird. Really weird. I don't know. We can run through and then trying to see what happens. 2, 4, 4, 2, 2, 4. I'm trying to understand, just kind of going through in my mind, see if there's any way that this could go wrong. I don't know. 80 and 98, that's 18. Right, we have 18 difference. That is a very interesting difference. Okay, let's come back down. And let's change this to 4 and 4. Alright, we'll rebuild it and we'll re-debug it. Okay, that's fine. We just keep pressing 2 1 1 2. Yeah, we got 6. And next is 2 4 4 2. Okay, 2 4 4 2. We shall 12. Next is 2 7 7 2. It should be 18. Yep, 18. Nothing from 3. But it's fine because next I'm just going to go 4. 4 2 2 4. Oh, 4 2 2 4. Oh wait, hold a second. That's not right. That's not right. Huh? That's not right. I'm looking at the wrong thing. What happened to 2772? We should have more than that. We should have 1, 2, 3, 4, 5. We should have 30 already. Let me redo this. Alright, this feels wrong. This feels very wrong. Okay. So 2 1 1 2, we get it. K is equal to 4, right? 2 1 1 2 is good. We need a 2 3 3 2. Yeah, we know 2 2 2 3 3 2, right? Okay, get counter. So the number, where's num? Where is num? 2 3 3 2. Yep, we got it. Total shall be 6. No, return total. So 2 3 3 2. Coming here. So total should be 12. Yeah, 2 3 3 2. We get 12. 2 4 4 2. We don't have 2 4 4 2. So 2 4 4 2 we shall not. That's good. Next 2 5 5 2 should be a yes. Right, num 2 5 5 2 is a yes. Okay. 2 5 5 2 is a yes. That running total is 18. Good. Next is 2 7 7 2. Right, 2 7 7 2 is good. Get 6 18. Become 24. Then 2 8 8 2 is nothing. 2 9 9 2, yes. 30. There we go. Okay, 4. 4004. Num is 4004. It's good. Shall give me 2. Alright, return total. Total is 3. Yeah, give me 3. So running is 30. Now current is 3. Alright, so 3. Then we have 4224. Hmm? 4224. Oh, because 2244 is already. Oh. Okay, I see. I know why. Oh, this is a subtle bug. So basically, the palindrome has to be valid first, and then to check. Okay. Alright, it's fine. So basically, we don't do it here. So we get a num, right? And we will do. Hold on. We'll put it here, and this one, we'll put this one here. Right? So basically, we get a number first, and we say if it is divisible and it has not been seen. And then we do this, and then we do this. I think we might have an extra. Okay, yeah, we just swap some places. Oh, let's try one more time. Yep, it has to be divisible, which means this has included before, and then we check if it has been seen before. So in that case, can we revert back to the previous check? Yes, this is the check I want to do. If this is good, then we're gonna submit it. Looks good. Let's submit. Solid. Very solid. Right? This is quite solid. It's quite a solid effort. Took a lot. Yesterday is like almost 1 hour, and today is 1 hour and 23 minutes. Yeah, this one takes time. It takes time. 298 and 65%. I'm not complaining. Not complaining at all. At 65. Yeah, I won't say this is like hard, but there is a lot of things to consider. I do think this is one of those good interview questions. Is it convoluted? Maybe. There's just a lot of things to go through, and then you really have to. I mean, at least for me, right? If you want to debug this well, you have to get a lot of refactoring done, right? If you don't do the refactoring, debugging is it's gonna be very painful, right? So you get debugging done, and yeah, so like all of this just can go through, and you have to have a lot of test cases to check. Yeah, it takes some effort. Enumeration, permutation, and combination. It's but look at this, so freaking simple. Like mine is, I don't know how many lines, 100 lines, 39 lines. I mean, minus a few for this and that. Is there a permutation proof. I don't know. What the hell is this? I think we're gonna just put it there or become one of the things that you never look at again. Yeah, this is all right. This is all right. Maybe I'll look into it, but I'm pretty sure this is a different method. I no longer post solutions, do I? Yeah, I no longer post solutions. But maybe we'll look into it. But I want to solve this one first because we never did. We just copy and paste. We never did, so I'll change the order. All right. Anyway, that will be it. That will be it. It's a long journey, indeed, a long journey. I think this is pretty easy to understand. Like it's not that difficult, but the intuition of finding how many uniques, that one takes a long time. I think yesterday I was able to get to the palindrome part pretty fast, but after I get to the palindrome part, I need to get to the count, and I was stuck there until afterwards I was washing dishes, and then it came to me, yeah, we can use a combination to do the palindrome part. Can do the counting, do the basically permutation, right? That's the intuition there, and then we brought those two ideas today, and trying to see if it works, and in general it does, but there are a lot of kinks to work through. There is the one that you have these repeats, right? You have 4A4 and A4 4A, like this. You have to work through that, and you have this zero thing. But I think I had an idea how to deal with zero yesterday, so that one basically was done. What else? What else was the difficult thing today? Yeah, this has seen was the difficult part that I did not realize, but I'd say that's the only one, right? I mean, we have to write a combination ourselves, which honestly is not that bad. It's not that bad, and no, yeah, the rest is just engineering effort. It's not that bad. I think the only one that surprised me was this. Have to keep track of what has been seen, and of course, we could have solved it like maybe 10 minutes earlier, if I had been more diligent in where this line should be put, right? Because earlier I put this line above, and then we run into some issues, and it took a while to debug. But then I realized, yeah, this line should be here. But overall, it was a decent effort, right? It was a decent effort. I'm gonna put this into a good interview question. Okay, that'll be it. I will see you guys tonight. Adios.